Elite volleyball athlete in a completely different way. I want you to imagine the volleyball player's body exactly like a high-performance sports car. We're going to dive right under the hood into the precise science, the underlying mechanics, and the meticulous engineering of jump power and capacity. Because, it's really not just about jumping high once. It's about building an engine that is capable of absolute, sustained, explosive flight.
Okay, let's kick things off with this incredibly stark number. 320,000. That is the estimated number of maximal, high-impact spiking movements an elite volleyball player might perform over an average 8-year international career. I mean, just sit with that for a second. Think about the sheer mechanical stress of 320,000 maximum effort leaps and landings. So right away, we see this isn't just a matter of having a good vertical leap. It's a matter of absolute durability.
To actually fuel that massive volume of explosive jumps without completely breaking down, the athlete's engine has to be incredibly tuned. It relies on specific energy pathways. You've got the aerobic system doing about 50% of the heavy lifting to sustain those long, grueling matches. Then you have the ATP-CP system at 40%, providing those immediate, explosive spark plug bursts of power. And finally, the anaerobic glycolytic system kicks in, kind of like a secondary turbo boost, covering the last 10%. Understanding this exact fuel mixture, that's the very first step in optimizing our jumping machine.
So here is our roadmap for today. 1. The ultimate jumping machine. 2. Decoding the vertical jump. 3. Force versus velocity profiles. 4. Testing jumping endurance. And finally, 5. Training for maximum flight.
Section 1, the ultimate jumping machine. Let's really understand why building this athletic engine is so absolutely crucial. The sheer volume of maximal leaping required in this sport is, well, it's staggering. We are talking up to 5,000 jumps in a single training week for national team athletes. Literally thousands of impacts. In a 5-game match, a player might execute 250 to 300 maximum jumps. And why do they do it? Because a massive 80% of the points scored in international competition comes straight from attacks and blocks. All of this happens in these highly intense rallies that last anywhere from 12 to 40 seconds, sometimes with as little as 4 seconds of rest in between. This clearly demands way more than just a casual approach to fitness. Because the physical demands are so astronomically high, the way we test these athletes cannot just be random. We can't just do it for the sake of logging numbers on a spreadsheet. As the research clearly states, the testing process has to be structured as a precise diagnostic tool. We need to extract the absolute maximum amount of meaningful data from a minimum number of tests, simply so we don't interfere with their already brutal training schedules.
Section 2, decoding the vertical jump. Let's pop the hood and look at the specific jump tests sports scientists use to diagnose an athlete.
First up, we have the countermovement jump, or CMJ. Now, this is your foundational diagnostic test. It isolates an athlete's general jump power and tells us exactly how well they utilize what's known as a slow stretch shortening cycle. Basically, by having the athlete perform a simple dip and jump, usually with hands on hips or holding a dowel, we can measure their raw lower body power. And we do this completely without the added momentum of an arm swing or a running start.
Moving on, we shift from general power to highly specific offensive power with the spike jump, or SPJ. Now, this test brings in the 3 or 4-step approach and that massive arm swing. Elite athletes should ideally jump about 3 to 5.5 inches higher in their spike jump compared to their counter movement jump. If they aren't hitting that benchmark, well, that instantly tells a coach there's a leak somewhere. The athlete probably needs technical work on their approach or maybe better upper body strength to transfer all that forward momentum into upward flight.
We also have to look at the depth jump. This is where the athlete steps off a box and immediately rebounds upward. It's the ultimate test of special jump power and the fast stretch shortening cycle. And when I say fast, I mean the muscle reaction happens in less than a quarter of a second. It tests how well an athlete's tendons and muscles absorb a high-impact drop and rapidly fire right back up. This is an absolutely essential metric for those lightning-fast block jumps at the net.
Section 3, force versus velocity profiles. Let's see how all of this testing data builds into a specific profile for each athlete.
By using force plates to analyze contraction time against jump height, we can plot athletes into this brilliant 4-quadrant matrix. Are they a high-force jumper but low velocity? Or maybe they're low force but incredibly high velocity. This metric is known as the Reactive Strength Index Modified, or RSI mod, and it allows coaches to give a pinpoint diagnosis. Think about it. 2 athletes might jump the exact same height, but one gets up there by muscling through with raw force, while the other bounces up with blinding speed. They are going to need entirely different training programs to improve.
So the crucial takeaway here is using metrics like the Dynamic Strength Index, or DSI. We are basically comparing an athlete's dynamic power, like what you'd see in a static squat jump, against their absolute isometric strength, which is essentially pulling against an immovable bar. This ratio tells us exactly what's missing under the hood. If the ratio is low, they've got the raw horsepower. They just need to learn how to access their top speed faster. If the ratio is high, well, they're already explosive, but their engine is simply too small. They need to build more raw torque and maximal strength.
To actually train this loaded capacity, coaches will alter the resistance during jump squats. They might use a standard barbell on the shoulders or opt for a safer postural alternative like holding a hex bar at the sides. Using the hex bar forces the neuromuscular system to adapt to jumping under heavy resistance, while simultaneously offering a completely different mechanical loading profile. It's a really smart way to train safely. Section 4. Testing jumping endurance. Measuring fresh power is great, but now we need to see how that power holds up under extreme fatigue.
Enter the Sheppard Repeat-Effort Test. This right here is the ultimate evaluation of a player's endurance. This specific layout maps a literal worst-case scenario rally on the court. It's designed to track a front row player's movements through an absolute gauntlet of physical demands. We want to see exactly how their body holds up when the aerobic and alactic energy systems are pushed to their absolute limits.
Let me break down just how punishing this is. The athlete performs a max attack jump, instantly goes into a lateral sprint doing 4 block jumps across the net, and then finishes with another max attack jump. And they have to repeat this entire sequence 4 times on brutal 20-second intervals. By tracking the exact percentage their jump height and speed drop across these steps, we discover the athlete's true jumping reserve. This tells a coach exactly who is going to soar and who is going to sink when it's match point in the 5th set. Section 5. Training for maximum flight. Let's bring all of this science together into practical application.
Coaches really have to engage in a delicate balancing act here. They have to carefully sequence generalized strength building, like your heavy lifting and basic aerobic capacity, with highly specific explosive jumping exercises. You can't just do plyometrics all year round, right? Without that solid base of general capacity, extreme specific preparation will literally cause the athlete's engine to break down and fail. And here is a super fascinating takeaway from the research. Just playing volleyball is not enough to maximize your vertical jump. There was actually a study done on Serbian league players that showed intense preseason volleyball playing improved their sprinting, sure, but it did absolutely nothing for their vertical jump height. 0. To engineer a higher jump, athletes desperately need targeted strength and conditioning off the court to fix those specific force-velocity imbalances we talked about earlier.
Ultimately, every elite volleyball program has a choice to make. With everything we now know about energy pathways, force velocity profiles, and dynamic strength indexes, I want to leave you with one vital diagnostic question. Are you just logging jumps and hoping for the best? Or are you truly engineering fright? Thank you for joining me on this explainer. I hope it helps you look at athletic performance in a whole new light. Catch you next time.